So welcome guys to Codeforces. That's a Div3 contest and it definitely has not started yet as usual. I'm not running late, not never, but I mean, okay, who am I trying to fool? The thing is just real men start at their own time though. Yeah, something like that. I'll have to edit this intro because that's true. Okay, so we are 5 minutes late because we wanted to. Oh, actually somebody already solved G, that's impressive. But we won't be like that, we will solve problems in order. So problem A, stone game. Polycarp is playing a new computer game. This game has n stones in a row. The stone on the position I has an integer power, AI. The powers of all stones are distinct. Each turn, Polycarp can destroy either stone on the first position or the stone on the last position. In other words, either the leftmost or the rightmost stone. When Polycarp destroys the stone, it does not exist anymore. Okay. Now Polycarp wants 2 achievements. He gets them if he destroys stone with the least power and the stone with the greatest power. Help Polycarp find out what the minimum number of moves he should make in order to achieve his goal. Okay, awesome. Yeah, we also have several test cases, which we will process like that. And we have a size of the array. We will create our array. We'll read it. What's next? We should find the minimum and maximum elements, right? Specifically when they're indices. So what is the minimum index? It's a distance from what? From the beginning of the array to what? To minimum element of which range? Of range from beginning of the array to the end of the array. Definitely can be written like that. We also want maximum index. Or rather, these names are a bit confusing, so I'm gonna call them index of min and index of max. Now, once I know these two guys, you may think about the problem in the following way. Actually, sorry for that. So we have an array, or actually I should, yes, that's an array. Here's minimum, somewhere here is maximum. Now we can destroy the stones in 3 different ways. First one is to destroy a prefix which contains both of them. Second way is to destroy a suffix that contains both of them. And the third way is to destroy one prefix and one suffix. In each of these cases, you can derive the number of deleted elements from the indices of these two guys. So what we will output is minimum of 3 elements, therefore we create a temporary initializer list, something like that. What is the distance if we delete a prefix? So we'll have to take maximum of these 2 indices, and I assume we will also have to add 1 because if these 2 indices are like 0 and 1, then we have to delete 2 elements, so therefore we add 1. Now, second case is suffix. What is suffix? Obviously we want to take minimum of 2 indices. Imagine these indices are like n and then n minus 1. So minimum will be n minus 1. So clearly I want to count backwards from n. Therefore, if these two guys are n and n minus 1, or actually they can't be because they are 0 based. So they can be like n minus 1 and n minus 2. And this expression is 2, which is exactly what you need. So there is no plus 1 here. And there's also one think about prefix and one option to delete a prefix and suffix. Now, because these things are getting repeated, I will actually create 2 more variables that will contain these values. So there was max index, there was mini index. Now what's the last option that we have here? Is we want to delete minimum index of elements plus 1. Because again, if minimum index is 0 and you delete a prefix of which ends at index 0, then the length of this prefix is 1. So therefore we have to add 1. And then I also have something like that, I suppose, because if this index is n minus 1, and you delete exactly 1 element, and this expression is also 1. The value of this expression is 1. So I assume that we can run something like that. Let's test it. So it compiles, it produces output 24532, which is exactly what we wanted. So let's get back here, go to submit, stone game, and just press submit. So we definitely took a long time here, but that's fine. Like, as long as we got accepted. Which may get hacked, I suppose, but I don't think so. We did everything like very accurately. That's the word. And it's good for educational purposes. Like, if you start on VCP and you obviously most of the time you will spend on implementation problems, like, I don't know, A, B, C, maybe even D in these 3 competitions. Then your goal is to actually optimize speed, but also minimize number of errors that you make. And writing clean code actually helps here. So that's fine if you spend like several more minutes, because in general you will get a good habit of solving problems accurately, which will come into play, which will help you later. So problem B, friends and Candies. Polycarp has n friends. The eyes of his friends has AI candies. Polycarp's friends do not like when they have different number of candies. In other words, they are communist, because it's natural for people to have different number of candies, and they don't like it for some reason. In other words, they want all AI to be the same. To solve this, Polycarp performs the following set of actions exactly once. Polycarp chooses k, which is from 0 to n inclusive, arbitrary friends. Let's say the indices of these guys are i1 through ik. Polycarp distributes their candies among all n friends. During distribution for each of total number of candies of these friends, he chooses new owner. That can be any of n friends. Not that any candy can be given to the person who has owned that candy before the distribution process. Okay, that may actually be helpful, because otherwise, like assume that it's not always possible to equalize. So number k is not fixed in advance and can be arbitrary. Our task is to find the minimum value of k which achieves the equality. Okay, driven by these constraints, sum of n is at most 2e5. We can conclude that something of an order n log n is fine here. In particular, also values are small. Okay. Let's write some code for input. I don't know. Sorry. So one thing we can always do when values are small is to compute a frequency array. Also, we have to work with the case when k is negative. First thing that we actually, should we do it? If you think about it, it doesn't sound like we should do that. Because if we create a frequency array of size 1e4 for every test case, and then there are 1e4 test cases, then we're using too much memory. So maybe the values are small not because we want a frequency array, but for their sum to fit into integer types and for newcomers not to experience overflow issues. Which I think is fine. Okay, but first things first, I assume that we have to sort because I have an algorithm in mind and it involves sorting. And also, it involves summing up the entire array. And I don't trust these overflowing bonds. Like it should not overflow, but that's always easier to just take some more bites and sleep well at night. Let's put it this way, in case Codeforces contests are in the evening for you. So the reason why we are doing this is because if this sum modulo n is not equal to 0, which is what it checks if you just leave it like this, then it's not possible to arrive at an even distribution no matter how hard we try. Because obviously the number of candies has to be divisible by the number of people. Okay, what should I do next? Actually, if you think about it, there is no need to sort, I assume, because what we really want, like every friend who has more than average number of candies, let's actually try it. Okay, so SRM is the average. I assume I should also call it sum. Now, the thing is, if a guy has more than average candies, and we have to take something away from them, that's like they are businessmen or whatever they are. Communism does not like that, such people. So we have to take something away from them. And then, if you think about it, like, once we took something away from every person who had more than average, then everyone is below average, and we have enough resources to distribute, to add them, to make everyone average. And that's exactly what we're going to do now. So actually we only want to count if of what? Of A begin, A end, I suppose. Then there should be some lambda expression which captures average. So and counts if Candies is greater than average. So no need to sort, no need to sync, in fact. Oh, I definitely was overcomplicated. And that's when I said like frequency array or sorting. No, you just want simple implementation. We get 2, 1, negative 1, 0, 0. Which is reasonable because in last two cases input is already equally distributed. In that case, in sort case, sum of all numbers is 10, 18, 23, 28, which is not divisible by 5. And in this case, we have to take 4 candies away from the second guy and distribute 2, 2. And in this case, we have to take from both guys who have 5 candies. So that's what we're going to submit for problem B. I'd accept it again. 10 minutes spent, it's fine as long as you write clear solutions. Like, we only use, I don't know, very simple constructions, like, and STL. So it's hard to make a mistake if all you do is call library functions, if you know what they are doing. So that's fine. Problem C, number of pairs. We're given an array A of n integers, so apparently people forgot to create a legend for this problem, unfortunately. Or no, even, okay, so both first problems had a legend. This one doesn't, unfortunately. So we want to find the number of pairs ij not equal, where the sum of ai plus aj is greater than or equal to L and less than or equal to R. That's it. For example, blah blah blah. First line contains an integer t. T-test cases follow. That's a common algorithm. To be honest, I don't really want to code it, but whatever. Like, but you can arrive to this algorithm if you just think reasonably. And there are 2 different ways to do that. One, of course, is with binary search, and the other, I assume, is with 2 pointers. So for both of them, you will need to sort an array. Actually, what happens? NLR. Okay, so first line actually contained more values than I was ready for. Do I really want to create a 2-pointer? Okay, whatever. So we'll implement a function which counts pairs up to, and it's a common technique, let's say, to then do things like that. So we count up to R, and then we subtract up to L minus 1. It will also capture an array A, which is sorted. So once we get into the function, we can assume that A is sorted. Now what do we do? Oh, actually, if you spotted that I forgot return type, then you're absolutely right. Something's wrong with my chart today, but let's ignore that for now. And also, number of pairs can be actually long, because it may so happen that all pairs are within the required range. Now what we should do is, imagine you have an array and you have some index L in it. Now for each L, you can find R of L, R, or I should say R, which is an implicit function of L, which is the maximum value, the maximum index you can take so that pair sum is at least such. Then for a given then it also means that we can take such pair, such pair, such pair, such pair. So these are all the pairs that we would. Well, let me just change the colors a bit. So I indeed have L and R. R is an implicit function of L. And I want to count one pair, two pair, etc. How many pairs actually? R minus L, because the right endpoint can be any of these R excluding this L elements. Then I have a 2-pointer for these guys. So what should I say? Let's actually, left gets 0, right gets n minus 1. Now, while left is smaller than right, we should do something, because like in this case it's important that R is righter than L, because we don't want to double count pairs. So while if A at left plus A at right, and you don't have to cast them to longs because they're up to 1e9, so sum is up to 2e9. If this is greater than makes pair sum a lot, then you want to decrement right. Else, you want pairs count to get incremented by right minus left. And you want to increment left, because that's how you do your 2-pointer. Now, that's not particularly ideal. We can make that while loop a for loop. So left is 0, left is at most right, and we increment left. Then you may run into problems if this condition results into right becoming smaller than left. So you don't always prefer for loops over while loops. Because in some cases, for loops may lead to wrong logic. So I assume this should be fine. It's like we only make one operation within each iteration of the loop, therefore we can't really break that invariant before we not detect it immediately afterwards. Right then, so it compiles, which is good. The answers are 2701. Let's think if it's possible that we missed something. Return type is long. We did not forget about that -1 because you want to include L. That means that you don't want to exclude it. And if you had L there, then you would exclude all values up to and including L. Note that this condition is strictly greater because if it's equal, then we are fine. We want to add this case in. So I think this is it for this problem. Let's submit. This is, of course, a classical problem, which you may actually know and therefore solve much faster. But yeah, you got accepted as well. As you can see, we are pretty consistent with our times, despite the fact that I am talking too much, maybe. Some of you think so, even that problems are not particularly difficult so far. Okay, so let's get back to our problems, and specifically problem D, which is another problem about dividing numbers. And I actually don't remember problem about dividing numbers, which questions the title of that problem. So we're given two integers a and b. In one term, we can do the following operation. Take an integer c, which is greater than 1, and a should be divisible by c, and replace. So we basically divide one of the numbers by their divisors. Our goal is to make a equal to b using exactly k terms. Okay. And you want just like when it's possible? It's almost always possible. It is almost always possible apart from special cases. Apart from when k is large, I assume. Or maybe something else I am missing. ABK. Let's see. Can we make that? 10 to the 4 square root. It's not particularly quick, which makes me wonder if we want clearly, because it's about divisibility, that means that you want to divide. You want to divide by factors, and therefore you want to find a factorization. But in order to find a factorization, you need to loop up to square root of the number that you're given. And we have quite some test cases, which makes me question if we want to factorize in a smart way or we don't. So let's assume that we don't, because that is not that fast, then not that slow, I should say, because actually it's quite questionable. What should we do here? Okay, let's just assume that you know more than like just factorization, and you know about sieve, Eratos fence sieve. So we initially create a vector of is prime, which contains values, which is actually a map, but with linear layout in memory. So what we do next is I assume S prime gets at 0 and at 1 gets false. What we'll do at the end is we'll filter through that list. That is fast enough. I actually remember using sieve up to 10 to the 7th elements, and that's also fast enough. So if is prime at I, and primes, let's push back I. I want to return primes. Somewhere around here we need a for loop. Is it safe? Let me think. Like square does not grow very quickly. In fact, we only have like 1000 here, so this is safe. Now, if S prime is D, then we want to look over multiples, starting at D squared, and with increments of D, and say that S prime at M is false. Actually, it might be wrong. It may be wrong. It may be wrong. I don't know, whatever. I forgot that we want to factorize and not just find primes. Therefore, it makes sense to compute minimum or maximum, I should say, prime divisor of a number. So initially we assume that maximum prime divisor of every number is equal to itself. And then I say like, okay, now if this number is indeed prime, then for all its multipliers, I want to say that their maximum prime divisor is D. Why? Because now we are able to perform wait, am I stupid or what? I actually wanted just primes. So stupid. Yeah, we wanted primes because it's loaded A equals B before the end of K moves. That doesn't matter actually. Like you can always say that, okay, let's perform all operations on A first and all operations on B. So that announcement was irrelevant. I would not make that an announcement. Because it doesn't change the problem. Like the it doesn't change the answer. Okay, so we got our primes. Now we can write a factorization function. So do we care about factors? Truth is we don't. We only care about the number of prime divisors. With repetitions. We initialize it to 0. The end will return that variable. We may have to break early to speed up our problem. Otherwise, if we have modulo prime actually I should say while n modulo prime is equal to 0, I want to increment the count of the divisors and also divide n by prime. If n is greater than 1, then I will also want to increment the count of prime divisors. It should be fast, right? The thing is that may actually only do it up to here, but yeah, it may actually be faster. Like we loop our all primes up to square root of a and b. If we don't succeed, then it means that a and b are primes. So we only loop over not that many primes. You will see that instead of looping over all these numbers, we will loop only our primes, and there are only 10,000 primes. So actually we have a speed up factor of 10,000 of 10 times. Which makes me feel more comfortable about what we are doing. But maybe it's completely unnecessary and you can just factorize like in a stupid way. I don't know. Maybe you can actually. Anyways, why do we want number of prime divisors? Well, you see, number of prime divisors is the maximum number of operations that you can perform on a number. So prime divisor count of A, count prime divisors of A, same for B. Now the truth is that if k is greater than let me actually call them like max operations on A, max operations on B. That makes more sense. Like we abstract from the value, the definition of that value to the meaning for our problem. So if so, then we want to output no, I assume. Otherwise, I want to say that it's always possible. Why? If k is equal to 1, oh wait, no, how could I be that stupid? That is incorrect. If k equals to 1, then we have to check one more condition. So if A modulo B, if A is not divisible by B and B is not divisible by A, then we want to output null as well. Because if you only have one operation and you divide one number, they won't become equal, and they have to be divisible by each other so that you can divide by the extra part and get two equal numbers. Otherwise, you want to print yes. That's like, that means that this means that A is not divisible by B, and this means that B is not divisible by A. If at least one of them is divisible, then we are good. Otherwise, if K is at least 2, and you can always make numbers A and B equal to 1 each. You start with like that many operations on A, that many operations on B, and you group them together before you, until you get exactly K operations. So because they are at least K, if we are in the else branch, then you can group them, group one pair of primes into one operation, another pair, etc., etc. So here the answer is yes. And maybe we terribly overcomplicated that. Huh? Oh, I forgot declarative function which I never defined. Listen. Well, the answer to the last test case is incorrect. Oh. So actually I was wrong. If they are A equals B, then we also can't do anything. Because beside the fact that they have to divide each other, it can't be equal. Can't be equal. So let's actually make a social experiment. So ignore sieve, ignore that. Now can prime divisors will be different. I want to explore it because if sieve is not always necessary, then it can save me a lot of time. I can save a lot of time by not writing it. Right? Instead of doing all that, no, actually that was fairly accurate. Yeah, so the idea is as actually what if n is equal to a square? See, we don't have good tests. We don't have good tests because okay, let's just add one and see how we miserably fail with such solution. So let's say that a is equal to 4 and b is equal, I don't know, 1, and we want exactly 2 operations. You can see the answer is no, but clearly the answer should be yes. So once we recompile it, it becomes yes. So yeah, actually, like here you have to watch out for it. Let's try to submit like that, because that is not that bad if you think about it. It's square root of 10 to the 9th times 10 to the 4th, but it's like on the edge. But to be honest, like sieve is not much faster, right? It loops over lots of integers, which is not good. A lot of primes, right? Primes are inconsistent values in some meaning of that word. Well, let's submit problem D without that code. So no sieve for us. Will it be fast enough? It's on the edge, right? Alright, let's submit with a sieve. Actually, I assume that the safest value, the lowest safe value to put here is that. I should actually put square root of 10 to the 9th. So something like that potentially. The answers have not changed. I rounded that number up, but that may not be, or is it enough? Okay, right on that. The reason why I want this small, because it will affect the number of prime divisors that I get here. And I get all primes up to that point, and if n does not have prime divisors up to that point, and it's a big, large prime number. So let's try submit again. Problem D actually. And see how much faster it is. So it's a million times faster. Okay, so you actually want sieve. But it also takes more memory. Like if you look here, then we use no memory whatsoever. And then sieve itself takes like 95% of the memory of that problem. Okay, anyways, problem E, funny substrings. And we definitely spend more time there. 20 minutes. Let's hope that we don't spend all that much time on problems that remain. So as you can see, sieve is useful, but sometimes solutions without sieve may also pass, if it's not intended to be like tight. So problem E, funny substrings. Polycorn came up with a new programming language. There are only two types of statements in it. X gets S, which assigns a variable name to X the value of S, where S is a string. Wow. For example, the statement var hello assigns a variable name named var the value hello. Note that S is the value of a string, not the name of a variable. Between the variable name, the assignment operator, and the string contains exactly one space each. So here and here. X gets A plus B, assigning the variable name to X the concatenation of values of two variables A and B. For example, if the program consists of three statements, A gets hello, B gets world, C gets A plus B, then the variable C will contain hello world. It's guaranteed that the program is correct and the variables A and B were previously defined, and there is exactly one space between the variable names. Okay. All variable names and strings can only consist of lowercase English letters of English alphabet and do not exceed 5 characters, which is convenient. The result of the program is a number of occurrences of string haha in the string that was written to the variable in the last statement. Polycarp was very tired while inventing the language. He asked you to implement your tasks for given program statement, calculate the number of occurrences of string haha in the last assigned variable. Okay, I assume that we can just emulate that because it will be quadratic in time, in the total length of all strings, of course. Actually, yes. If you think careful, that X definitely creates a lot of long strings. And then come end statements, am I right? Okay. You see, mostly when we concatenate strings, mostly the number of occurrences of haha stays the same, except for what happens on the boundary. Now, our goal is, of course, to avoid recomputing everything. So what we'll do instead is overloads operator plus. We also need that string info. I also need a constructor, so let's get string length. Now haha count gets. Can we count them just like this? Like haha is reasonably small, so we can just loop over. Okay, that's not ideal, but now you see I don't care about worst case because so while we found a position, oh, we already changed the value of the position, so all we want to do is to increment haha count. We only need 3 characters because if you take 4, like imagine that you're adding 1 string and concatenating 2 strings. All ha-has that can come into existence because of that operation, they have to be either like that, or like that, or like that. Everything else belongs to one of the strings, so you only care about suffix and prefix of length 3. But length of the string may be shorter, so that's why. The length of the suffix will stay the same. And then the starting position is length minus . Now let's think, if length is 3 and PS length is also 3, then we actually want to take that, which sounds reasonable. Now, how do we add 2 strings together? How do we add 2 string infos together? So its length will get, actually is length necessary? Let's think. The correct answer is no, I assume. So actually we did not have to. Buzzer. Yeah, we don't care. I assume that this returns unsigned, so therefore we'll have to do that. Or maybe it will figure out. Oh no. We needed this because it's also here. It's okay. Concatenation prefix gets what? Gets this prefix plus other prefix. I imagine that you can close that one. So my idea is that we can obtain the prefix of concatenation, because we only care about length 3 prefix. We can do it like so. So like we kind of concatenate them together in case first one was short. and we take whatever is the reasonable size. But here it's a bit different, so because we want I want to take that lens because I need it here. I assume that I subtract that from it. That's a start. And then I also want that variable, whatever. How do you call such an operation when you trim a string? I don't know. Well, the idea is that we take that many last symbols. In concatenation haha count gets haha count plus other haha count, and we also want to add haha count in one string. So we'll do like that. Sorry guys. Count occurrences of string. And the reason why I'm doing it like this, because I want to also invoke count occurrences. On what? On a suffix plus other prefix. And I want to return concatenation. And that's far from over, actually, because now we have to parse the statements. You may actually notice that I did a bad sync. Because what I really want is to count pattern. This is useful because now we will actually we'll be able to do that. So this tells us that the operation is assignment. And we have to split. So painful. Oh, I could actually, okay, okay. So this is incorrect. I have a couple of operands. With idea like that, I always read variable and operation. If operation is equal to that body, then I want to read value. And what I want to do is to say that map at variable gets string info of value. Else operation is equal to addition, to assignment of, to assignment which is actually addition. So I should write into first operand and into operation because I want to discard addition sign, and into second operand. Now both of these should be names, variable names. How do I proceed then? I said map of variable gets map of first operand plus map of second operand. And luckily I declared an addition operation for strings, which returns a new string object and doesn't change the current object whatsoever. So it should be good. And also notice that variable contains the last variable name that was used, so I should be able to access the answer just like that. Now obviously it's very error prone, but hopefully the fact that we went with an object-oriented approach will actually help us. Input file of problem E. Okay, cool. The first error is count occurrences cannot convert argument 2 from, oh, that's right, because I said that it's a string reference, but haha is not a string reference. Haha is a string. No appropriate default constructor variable. I admit that I should have an empty constructor for you. std mean no machine overload function found on line 24 as expected. I think we want 3u here. Still not so, so let's say we static cast to size t. Should always work, right? Right, next error is on line 27 for the same reason. Okay, now it compiles, which was relatively quick. But now it's stuck for some reason. So I imagine something went wrong. let's do some debug. I know you can barely see anything at that moment, but please bear with me. It's much simpler to do debug when you can actually see everything that happens. At the same time, and not like, okay. For whatever reason we got stuck here. Because I forgot to increment position. Therefore we were finding the same string over and over again. Maybe actually now remove all the debug statements that I just wrote. The answers appear to be correct. They actually are not, because I'm pretty sure that haha count should be long. Pretty sure. That will easily overflow addition. Let's say that count occurrences also returns long. Not that it can return long, but this way. No, okay, I don't want to risk it, I will just say. No, haha count of this string is already long, so pretty much everything here is long. So I don't have to do anything smart. We may actually observe that this was incorrect. If you want, so you can add one test case, and then this says 15. Right? Nah, I'll go with 50. So this is 14, right? Statements. 28, 42. 3, 4, 5, 6, 7, 8, 9, and then the initial one is one more. As you can observe, clearly our answer to the last example is incorrect. Now imagine that we changed it so that it's now long. Now we can actually get the adequate answer. Okay, let's go ahead and submit our code, probably without extra comments. Excuse me? Oh, how did it actually work if this, okay, like you can see that here there is no reference, it's a temporary variable, so it's unclear how it actually worked. Whatever. I assume that now there should be no compilation. But wait, that actually means that this gets copied. Which is not ideal. Like, every time here will make a copy, but I assume that it's fine because these initializer strings are actually short. It got accepted in 62 milliseconds, so fairly efficient if it works. We have 55 more minutes, and apart from my heart and back, nothing stops us from getting 2 more accepted. Actually, as you may have noticed earlier, I accidentally clicked on standings and pretty much everyone already finished because problems are not difficult. That's the thing that we are explaining a lot of solutions carefully, very explicitly, explaining everything. Second trial apparently joined an hour late into the contest. And you may actually see that some people do face issues with some problems. And by judging by the fact that we solved F, we should be able to solve F fairly easily. Also, a lot of people have problems with D, which I'm not sure why. Or maybe they didn't write the sieve and then they were like, oh, it doesn't work. We got it. We got it. Actually, which one of them will be considered for like system tests? Oh, there are no system tests, but hacks. Which one is considered for hacks? Okay, can I hack my like first submission and then I lose everything? I don't think so. Like I have a second submission, right? So maybe they didn't use the sieve and their code was not so efficient as ours. Maybe they didn't have. Well, maybe they have a different statement, like d up to square root of n, which gets computed once. I don't know. Anyway, problem F, interesting function. It's almost like Lewis Hamilton's interesting tactics, but interesting function. So we're given two integers, L and R, where L is strictly smaller than R. We'll add 1 to L until the result is equal to R. Choose, there will be exactly R minus L additions performed. For each such addition, let's look at the number of digits that will be changed after it. Changed digits always form a suffix as a result, blah blah blah. Output the total number of changed digits if you want to get from R to L. That is actually interesting. I never thought of it. Let me make it bigger because it's impossible to see anything. Okay, one thing that may simplify the problem immediately is I'm going to say this and count digit changes up to will count digit changes up to. That's what it does. And I think that it can be actually long. So this should start counting from 0 and 1, 0, 1, next number, including this body. So just like that, it's always useful if you have like such interval problem to simplify it. So say like your intervals always start at the beginning. It may not be actually optimal, but I assume that we will find it much simpler. It actually sounds way too simple to be true, but digit changes count shows at 0, return at the end. So if I think about it, last digit always changes. Okay, that's boring problem. I never thought of it because it's boring. Okay. You'll see. Because what happens is that last digit always changes, continuously changing. It's its nature. Then you get 10. And the last digit actually also changed, but then you also get that difference. So I assume that you can do just this. While max number digits changes count plus equals max number. Because if last is 10, then we actually had exactly 10 changes. And max number gets divided by 10, and that's the entire problem. If it's true, then it's like nonsense. That problem is not a diff3f. It's like D it must. I admit I made a mistake in such an easy problem. I actually made another mistake. Because I assumed that I want to count L inclusive. Because we don't want to change. Yeah. Looks fine. You just count how many times each digit changes, and that's it. I don't really know what this problem is all about. Can anything there belong? Not really. L and R are regular numbers, and then you just add it to digit count. And digit count actually is also short. Because from 1 to 10 to the 9th, it's maximum number of digit changes that you can ever get. You will never get more than in this test case. And you don't overflow here, so you don't overflow ever. I don't know what it was all about. It took me 8 minutes, which is the shortest of all problems. Well, problem A I actually solved like in 6 minutes because I was 5 minutes late, but still, that is not problem F. I mean, it's educative in the sense that you want people to read all the problems, because problem setters put some effort into preparing those problems, but it really makes no sense. It really makes no sense. Problem G does not take that much time, so you should be able to solve it as well. 1 second. Okay, I'm sorry, I am back. This problem G. Problem G gift set. Polycarp has X of red and Y of blue candies. Yeah, he wants to make gift sets. Each gift set contains either A red candies and B blue candies, or A blue candies and B red candies. Any candy can belong to at most one gift set, but we don't have to use all candies because at most one. Right? So help Polycarp find the largest number of gift sets he can create. Sounds like another stupid math problem, honestly. I don't even know what's I'm doing here. Okay, we read test cases with just so boring. It's Okay, we read the input. Now, maximum number of gift sets that he can create. The thing is that you obviously can't... a stupid algorithm would be as follows, like, whichever is bigger, like take more of that color, right? But that doesn't actually work, so... Let's write a condition that determines if we can create one set. Condition is like this. We also want to count number of gift sets, which will never overflow. Because at most you will have like x is equal to 10 to the 9th, y is equal to 10 to the 9th, a is at least 1. So you will never have more than 10 to the 9th gift sets. And I also wrote this condition incorrectly. Now, normally we would say like if x is greater than y, x gets decremented by actually that was a general, so we can assume that a is at least b by swapping a and b. So if then our solution looks like this. It is incorrect. It's correct, it's not fast enough. B, A. Don't have to check that again, because you're creating the most efficient. Let's just check that it's correct. It will take some time, but then it processes and it's correct. It's obviously very slow. Why? Because one of these operations may be performed multiple times. Like, they are very slow. A and B are equal to, I don't know, 1, and x and y are very large. So what you should do instead is you think, what happens if I make multiple operations? So I decrement x by k, A, I decrement y by kb, and I increment c by k. How do you select k? Well, oh, actually, is it? It's not going to be fast enough, right? I have to add one more test case. Nine, 2, 1. Yeah, okay, my idea was to batch operations to perform them until this condition becomes false. In some sense, unfortunately, that's not always possible. That is not always possible. The idea to determine k was that I want a x minus k be less than y minus k times b. From here you can somehow obtain k, inequality on k. And I also wanted k to be smallest such integer, therefore I would have one more inequality on k, which then results into something smart. But that doesn't work. In fact, I assume that we'll need something smarter for this. Okay, let's imagine that we created C sets where there are A reds, in D sets where there are B reds. Then we have such conditions. And we want to maximize C plus D. Suppose that we know value of C. What is the maximum value of D that we can take? Suppose that C is given, right? Then you can say like, okay, I'm going to isolate D. So here I divide by B, here I divide by A. And therefore D of C is equal to minimum of this and this. I may actually want to preserve them. Also, obviously, C is at most maximum of x over A, minimum of x over A and y over B. Now you can notice that D is monotonous in C, and therefore our let's plot here C, here are C and D. Okay. C of C is this function. Now D of C is something like that. Not necessarily like that, actually. It may be steppy, which is not cool. It may actually decrease quite quickly if B and A are quite different. If B is like 10 times bigger than A, then increasing C by 1 will cause this thing to decrease by 10. This thing will won't almost change. That's imprecise. It can be like 9, 10, 9 or 10. which is problematic. It's almost like you have something like that. And then, I don't know, then the other guy becomes a smaller of two. And you want to find the maximum of such an expression. How the heck do I do it? I mean, I obviously can't loop over all possible values of C. My hope was that their sum will look like this, and therefore I will get an easy ternary search to work. But now I don't know what to do. That is actually very strange. I need to take a break. I'm gonna take a break. Okay, so I managed to get accepted on G, but I don't trust in my solution whatsoever. Basic idea is that I want to subtract so that I get towards 2 zeros simultaneously, and because of that there's some called optimal value of D, which is now obviously, which I don't have a proof that it's optimal, but you can derive it. So like you try to take such bags that your x and y tend to 0 at the same rate, so to say. So it's really a heuristic solution. It is the way it is. And I actually encourage you to try and hack it. I didn't really want to record how I implement it because it doesn't really make sense, practical sense. But basically I think that optimal value of D is either one of the endpoints or this so-called optimal value. So therefore I try like small values, near optimal, and then large values. And all this time I check if it works. So I take maximum of limited number of options that I wanted to consider. Now it takes like almost 1 second. I assume that if it's correct, then you can reduce heuristic magic. If it's incorrect, then setting heuristic magic higher won't help. So that's a challenge for you. Try and hack this submission because I don't believe it. But like I had to submit something, so that this is my best guess. Okay, I guess that you want either small. I actually think that you want this value, like more or less optimal D or optimal D minus 1 or optimal D plus 1, like rounded. That's what I actually think. But because it's heuristic anyways, I decided to just make myself a little bit safer by considering a larger space of possibilities. And I actually let people know that it's heuristic. So like I don't hide it. I just say like that's heuristic. If you want to, come and try to hack it. It will be actually educative for me because I honestly don't understand this problem very well. Like what I see is that I want to optimize function which looks like something plus minimum of some two values, and my problem is that these values are rounded. And I don't think that anything like ternary search works for this. Because I don't think that if you have like linear functions and then round them, I'm afraid the result is no longer linear and it's not a rounded function. It's not a rounded linear function. Let's put it this way. So the space of rounded linear functions, I'm afraid, is not closed under addition. Maybe I'm wrong. If I'm wrong, then you can just check endpoints, but that's strange. And also you want to check that middle value when when two expressions in the minimum are equal. That's exactly what I call optimal D, when these two expressions are equal. I'm afraid that if A and B are large, then heuristic magic of 2,500 is not actually enough. Because these expressions may be equal far away from that special point that I computed. If you also find it sus, again, I encourage you to hack it. I will be happy to get hacked and learn, hopefully, something. That's it. That's it. Please hack. Please. Obviously, I won't pay you money or anything like that, but you will get psychological joy of hacking somebody. So yeah, please hack. That's it for me for today. So thanks for watching, everyone. If you got any questions about other problems, don't ask me about this one because it's obviously heuristic. So I can't explain much like in ideas why something works. But if you want to ask about previous problems, why something works, you can ask me in my Discord. I think I will manage to put the link down in the description, but if I fail to, you can ping me in the comments. That's also good if you ask in the comments. It helps with YouTube algorithm, I assume. So I didn't actually test this hypothesis, so I may be wrong. If you know more about how YouTube ranks videos, also let me know. So that's it for today. Thanks for watching and bye bye.